Alright, welcome to your quick math tutorial on converting between units. Let's get straight into this with an example. Alright, so let's say we had the question, Joe weighs 14 stones, convert this to kilograms or kg. So the first thing we want to do is that we want to find the appropriate conversion factor between our kilograms and our stones, and it just so happens that 1 kilogram equals 0.157 stones. So we have our conversion factor. So what's the next step? Well, the next step is that we want to convert our 14 stones to kilograms. And so the best way to do this is that this is the most easiest and efficient way, is that we want to treat our units here, our measuring units, as variables. So the same way you would have something like 5a. It's the same thing, for example, as 5 kg, right? Our units in this case would be called our variable. So we treat our units as variables and then simply cancel through. So we'll write out our value again. So we'll write out as 14 stones. And we're going to write 14 stones equals 14 stones multiplied by, and now we're going to write our conversion factor here, but we're going to write it in a ratio form. And what we're going to do, and you'll see why later, is that we're going to place our stones at the bottom. So we have 0.157 stones. And we're going to place our kilograms at the top. Now, since 14 stones here is associative, right, it gets multiplied through, the 14 stones would end up on the place of the numerator. And so since we have 14 we have our stones on the numerator and we have our stones on the denominator, we can simply cancel through. So we cancel our stones. And so what we're left with is 14 multiplied by 1 kilogram divided by 0.157. And then we'll simply plug those results in the calculator and we attain 89.172 kilograms. And if we were just to write that, we'll write that to two significant figures. We can say 89 kilograms, 89 kilograms. Right, so we can see that 14 stones equals 89 kilograms. Alright, so we have our 89 kilograms here. So now what if we wanted to convert this 89 kilograms to pounds? Well, it's the same process again. We're going to look for our conversion factor. We can look at the back of our textbooks, our maths textbooks, or you can simply use Google, and you'll find that 1 kilogram equals 2.205 pounds. So we have our conversion factor. So the next thing we want to do is we want to rewrite our values again. So we have 89 kilograms equals 89 kilograms multiplied by, and then we'll write our ratio in here. And since we want to clear the kilograms and we want to put pounds in its place, we'll place our kilograms at the bottom here. And so we'll have our 1 kg equaling 2.205 pounds. Close brackets, and then plug our values into the calculator. Well, first off, we want to rewrite this as 89 times 2.205 pounds, and then that will all be divided by 1. The kg has been cancelled, so we divide that by 1, and we'll plug our values into the calculator. And we attain 196.245 pounds. And of course we can write that just to three significant figures, which is 196 pounds. Alright, so moving on to our next question, we have light travels at 186,000 miles a second. Convert this to kilometers a second. Alright, so notice in this case that we are not doing anything with our time units. They remain the same. That stays in seconds. What we're doing is we're converting our miles to kilometers. And so we want to find a conversion factor which shows us how many miles is in, or how many kilometers is in a mile. and we know that 1 mile is equal to 1.609 kilometers. And so we have our conversion factor, and so the next thing we want to do is that we want to write out our values again. So we have 186,000 miles a second equals 186,000 miles a second multiplied by, now notice our miles here is in the place of the numerator and our time unit is in the place of the denominator. And so since our miles unit is in the place of the numerator, we're going to place our miles at the bottom here. So 1 mile is equal to 1.609 kilometers. And now we're in a position to cancel out our miles. So we can rewrite that again. We'll cancel out our miles. And so we are left with 186,000 multiplied by 1.609 kilometers, and then divided by, since the mile is cancelled, we have our time unit left at the bottom, so we have our seconds, and then we'll put that into our calculator, and we attain 299,274 kilometers a second. And of course we could round that to our nearest thousand, which will give us 300,000 kilometers a second. So we know how far light travels, how many kilometers light travels in a second. It travels 300,000 kilometers a second. Alright, let's move on to our next example. So we know that light travels at 300,000 kilometers a second. So what if we want to convert this, instead of kilometers a second, we wanted kilometers an hour. We wanted to see how far light travels in an hour. Well, notice again, before we were paying attention to our distance units and the time remained the same, but now our time units are changing and our distant units remain the same. And so we want to find a conversion factor which converts our seconds to hours. And it just so happens that 1 hour equals 60 minutes and 1 minute equals 60 seconds. And so 60 minutes must equal 60 times 60 seconds, which equals 3,600 seconds. And so 1 hour must equal 3,600 seconds. Now we have our conversion factors there. So the next thing we want to do is we want to plug this into our equation. So we want to make it a ratio. All right. So what do? We have 300,000 kilometers a second equals 300,000 kilometers a second multiplied by, now we want to write our conversion factor as a ratio, and since we want to convert our seconds to hours and our seconds are in the place of the denominator, we are going to place our seconds here in the place of the numerator. So we have 3,600 seconds at the top and we have 1 hour here at the bottom. And then we simply multiply through, right? We're going to cancel our seconds. We have a second up here unit and we have a second unit down there. And so we are left with 300,000. And since our km is commutative, we could write 300,000 times 3,600 km over, and what we're left with? We're left with 1 hour. And so we'll plug that into our calculator, and we attain 108 billion kilometers an hour. So light travels 108 billion kilometers an hour, which is approximately the distance from the Sun to Saturn. Approximately 108 billion. which would mean that a being living on Saturn would see the sun as it was an hour ago, because the light from the sun takes an hour to reach our being on Saturn, our Saturnian being. Alright, that was quick math. Thanks for watching. If you found this content useful, don't forget to like and subscribe, and I'll see you again soon. Bye bye.